So then, proper questions. Question 1 on page 315. This is chapter 21.3, the first question. I've got to complete the table of values for sine x. In other words, I'm going to plot the line y equals sine x. Well, it's a lovely shape. You just wait and see. Right, all I did was substitute, for example, minus 360 into my calculator and then found the sine of it. Minus 180, it was 0, which is the one I did down there as a demo. All you do is shove it into your calculator. Sine minus 180 equals, and you get 0 degrees. So I worked out all these values, the ones I had to do. For example, sine of 45, dead easy, isn't it? Is 0.71. Again, just standard trigonometry. Ask your calculator what it is, and then we plotted them. Well, I plotted them. That's what you're going to do as well. And that's the shape we get. It's a beautiful, beautiful, beautiful sine curve. Look at that. So what do we got? We have the point 0, 0. So the sine of 0 degrees is nothing. The sine of 90 degrees is 1. The sine of 180 degrees is 0, etc. The sine of 270 degrees is minus 1. So you get a single sine wave looking like that. And of course you can go 2 rotations and go up to 720, for example. And you can rotate in the other direction, in the clockwise direction, end up with negative angles, and they'll still have a sine, and hence the same curve. It looks just a continuum all the way through from left to right, as many turns to the right or left, clockwise or anti-clockwise you want to do. So that's the classic shape of the graph of y equals sine x. It's really beautiful. Right, now let's just begin to do this. Use your graph to find all the values of x, in other words the actual angle, when the sine of this angle is 0.5. In other words, if sine x equals 0.5, x is going to be what? And there's going to be 4 answers. I'll show you in a minute. So let's just take a look. So this is the y-axis, and therefore if y equals sine x, then I need to draw in the line of y equals 0.5, and I'll do that now if I'm allowed to. 0.5 is going to be about there. So again, I won't read it off the graph. I'm just going to draw in the line to show the examiner what my brain did. That's y equals 0.5, and there's a solution there which we read down. There's a solution there, read it down. There's a solution there to the equation, and the last solution is that one right there. Either I can read it off the graph if it's very accurate, or better still, use the graph to help you to calculate it. Now, back to the previous video. I did something like this, didn't I? Yep. And I'm told that sine of the angle is going to be 0.5. Therefore, I'm going to ask my calculator what the angle is. Now, how do you do it? Just go shift sine, don't you? So shift and sine 0.5, and that gives me an answer of, if you can see that, it's 30 degrees. So the angle I'm playing with is 30 degrees, and all these solutions, that one, that one, that one, that one, are all related somehow to 30 degrees. You've got to cast your mind back to the first video. So something like this then. Right, what have we got? So this is our first 30 degree angle going that way, anti-clockwise, positive. So straight away I've got one solution. The next angle stops right there. So if this is 30, then this must be 150 degrees. So there's my 2 solutions so far. What have I got? That one must be the 30 one. This one has got to be the 150 degrees one, isn't it? Yeah, because it's 30 degrees short of the 180. As you can see, 180 to there, and it's only 150 because this part is 30, so I just did it by subtraction. So that's my 2 solutions so far. Now, the next one is here, which has gone 30 degrees beyond the minus 180. Well, let me see how that works. What did I actually do? I started here, and I want to go in the negative direction, so I went to 180 plus the extra little 30 there. So we've got 180 plus 30, which is basically minus 210 degrees. Do you see how I did that? Please note, anti-clockwise is the positive direction and yields the 2 positive solutions. Clockwise, I know it seems backwards to the human brain, clockwise, starting from 0 degrees here, gives you all the negative answers. And look, I had to stop here because that's where the line is, and I told you all these solutions are based upon 30. So that little bit there is the 30, so I went to minus 180 minus another 30 is negative 210. So that's another solution. Now the last one appears to be 30 degrees short of minus 360, and I can show you why that is straight away. So I'm starting from 0, there I go, minus 90, minus 180, minus 270, and stop there. So as you can see, if I go in that direction, in the negative clockwise direction, I've not quite reached 360 right there. I've gone all the way around. 270 plus that extra little bit is going to be 360 minus that 30, which is minus 330 degrees. I'm sorry, that 210 should be negative as well. I just forgot to write it. Is that okay? So these are the solutions then. The positive solutions are 30 degrees and 150 degrees. My first negative solution is an extra 30 degrees beyond the minus 180, so that's going to be minus 210 degrees. And the last solution is going to be 30 degrees short of the 360, minus 330 degrees. And that's the three solutions. I'll pause there and plan the other parts of the question, because each one is going to take this amount of time, even though it's one question. Part 2 says I've got to do the sine of the angle as 0.14. Therefore the angle is going to be, well, I'll just calculate it here as 8 degrees. So here I go. If I do some little calculations, see if I've got the space to do it. If the sine of my angle is 0.14, then by pressing shift sign, I'll write it for you. So the shift sign of 0.14 equals 8 degrees. So basically my next little set of quadrants will be based upon 8 degrees and not 30 degrees as before. So if I'm playing with 8s, I can jump straight into my little calculations. So if I put it over here then, so the sine of my angle was 0.14, so my first solution is 8 degrees, would you believe? So if you like, that one would be 8 degrees. If I draw the line y equals 0.14, I'm not going to try and squeeze it in there or make a real mess of it, but I'll do it anyway by calculation. So if this is 8 degrees here, again, if that was 8, then my next solution is going to be 180 take away that 8, isn't it? So instead of playing with 30s, I'm playing with 8s. So my next one's going to be 180 take away the 8, which is 72 degrees. Sorry, 172 degrees. All right, two positive solutions. Now I'll do my negative ones. Right, my negative solution is going to be sort of here somewhere, a little bit after the minus 180. So I'm starting from here. I'm going minus 90, minus 180, plus the extra 8. It's going to be minus the 180 and the 8 on top of that, which will be minus 188 degrees. That's my first negative solution in this sort of position here, roughly there. And my last negative solution is going to be the negative answer to 360 minus the 8. In other words, I've come all the way around to here, minus 90, minus 180, minus 270, let's work on this one, minus 270, and all that, but this little bit is going to be 8 degrees, so 360 take away the 8, and that's going to give me 352, so the answer is minus 352. What I've done, I've started here, gone all the way around, and landed about here, but it's only 8 degrees instead of 30. It's really thin slice, isn't it? And there's my 4 solutions to the equation sine x equals 0.14. I've got 8 degrees, 172, minus 188, and minus 352. I'll pause again and look back at the other question. Okay, here we are from the front page again. So we're now going to do this one here. I've got the sine of x is 0.8, and I'm going to write it down here. So if I go shift sign, oh, it's a bit glitchy. So shift sine of 0.8. I actually made it, I can't remember. So shift sine 0.8, yeah, 53.1 degrees. I want to call it 53. So 53 degrees then. So we're playing with 50 degrees. Here we're playing with 8 degrees. Here we're playing with 30 degrees. It's the same thing again. Something like this, that'll be 53. That's going to be 180, take away the 53. I'll do the calculations on the other side. Again, we're based on 53s now, and I think I better work up here. So first answer then, I've got the sine of x is now 0.8, and my first solution is going to be 53 degrees, so that'll be the equivalent position, say about here, in the positive direction. and my next one's going to be 180 take away the 53. So if that was 53, say, then for my next solution into the second quadrant, I'll be doing this. So that's going to be 180 take away the 53. So I'll write it down as my calculation. So 180 minus the 53, that looks like 127 degrees to me. Yep. So that's my two positive solutions. Again, 127 will be about here somewhere, won't it? Because if point 8 is across there, I've got a solution there and there reading down. Alright, so that's what I've got. Right, moving on, let's do the negative solutions. Let's go back to red then, so it stands out, it's different. So how do I get the first solution? Well, first solution is going to be about here. It's going to be 53 degrees beyond the 180. So imagine I'm working here. Instead of working with 30s, I'm working with 53s. So minus 90 minus 180 plus an extra 53 degrees. Alright, so it's going to be 180 plus the extra 53, but of course I've gone on in the negative direction because I've gone clockwise. Right, so what have I got here? We're going to have, let's just whack it in, 180 plus the 53, answer 233, in other words, negative 233 degrees. So what I'm saying is, starting from here, go all the way around, hit the 53 degree line beyond the 180 and get minus 233. And the final solution would be this one here, which is going to be 53 degrees short of the full 360. So x is going to be the negative answer to 360 minus the 53, and that's going to give us, what's that, 107, 207, 307, so it's going to be negative 307 degrees. Is that alright? Let's just do it on my calculator in case I've made a mental error. No, it's 307, therefore it's negative 307. And I'll pause again and look at the next one, and I'll get back to you immediately. Right then, next one along, the sine of x is going to be 0.71, so I want to work out what the x value is going to be. So I'll just do it down here quickly. I've got sine x equals 0.71, so therefore I'm going to go shift sine of a 0.71, gives me the actual angle, and I made that 45.2. Now we'll use the 0.2 this time. There's none to guarantee in an exam you get just whole numbers of degrees, so let's go to one decimal place on this occasion. So instead of playing with I don't know, 53s there and 30s there, today we're playing with 45.2 degrees. So let's just write this up somewhere where I can find some space. So I've got the sine of x equals 0.71. Therefore my first solution is going to be shift sine that, and I made that 45.2 degrees. My next solution is going to be 180, take away that 45.2. Again, just like working anti-clockwise here in the positive direction. So we, if you like, 45.2 there, go all the way across to 180 minus that 45.2, and let's show that calculation. 180 minus 45.2, and that'll give me the second solution. We have got 134.8 degrees. 134.8 degrees, second solution. So if you like, that's like the 45.2 reading down, that's like the 134.8 reading down. As you can see, if you had to read down from the graph, it wouldn't really be possible. You can't actually judge this to even to 1 degree, let alone one decimal place. But this is, I'm using the graph to help me judge whether it's going to be a positive or negative solution. Now we'll do the negative solutions. You may recall we go around this way now, so 0.71 is about here somewhere, so there'll be a solution roughly there and there, two negative solutions. So if we're based on 45.2s, so if you like, I'm starting here, I'm going 180 plus the 45.2, the equivalent to that little slice there, but it'll be a negative solution. So I've got 180 plus the 45.2 and put a minus in front of it, so 180 plus 45.2, 225.2, but it's negative because I've gone all the way around this way beyond the 180 by an extra 45.2 degrees. And the last solution is going to be the negative value of whatever 360 is. Remember, we're going to go all the way around apart from the little bit there, and that little bit is now 45.2 and not 30 as per the original picture. So take away the 45.2, make it stand out a little bit better, I think. So 360 minus the 45.2, and that's my last solution here. So 360 minus 45.2, I've got 314.8, but it's a negative value all the way around here back to there. Alright, and I think I've got one more to do, but it's not going to fit on this grid, so I'm going to pause and look at it and get back to you. Yeah, last one. The sine of the angle is going to be 0.98, and I press the shift sign like I did with all the others, so the angle is actually 78.5 to 1 decimal place. Alright, so let me just write this up somewhere. I'll have to do it in yellow and do it a little bit thick so it stands out. Right, so where was I then? Ooh, that's really thick. So the sine of the angle is going to be 0.98, that's the last question. So the angle itself, if I go shift sign, is 78.5 degrees. That's a 7 and not a 2. Alright, so that's, if you like, the first position there, the first positive solution. The next one's going to be 180, take away that. Here's my next positive solution, and that gives me 101.5, 101.5 degrees. So first, second solution. Then we'll go red, it lets me. Now the first negative solution goes along here somewhere, so it's going to be the extra 78 degrees after the minus 180. So my negative solution is going to be minus 180 plus the 78.5 degrees. This is so fat, can you even see it? So 180 plus the 78.5, 180, press the wrong button, 78.5. Right, that's going to be negative 258.5 degrees. I've gone all the way around here. Where am I now? All the way around here. 180 is there plus an extra 78. We'll be practically up there somewhere. Doesn't matter how it looks, it's just a diagram to help us visualize what we're doing. And the last solution, of course, is going to be the negative solution of 360, and then we're going to take away the 78.5 degrees. So the answer will be minus, so 360 take away the 78.5. Answer is minus 281.5. Alright, and that's the four solutions to that. I'm sure this fat red stuff doesn't really stand out against the blue background, but it's a lovely towel. I took a picture of the towel and just blew it up, and we're writing on a towel right now. Don't do it at home, your mum will tell you off. But there you go. That's what we've got here. We've got 1, 2, 3, 4, 5, 6, 5 different questions all on one. Ugh, right, that's quite long. You won't get all this in the exam. You get, say, I don't know, drawing a line and get 4 solutions and not millions of lines. That's it. That's question 1 done on page 315, the first proper circular function question. And it's as hard as it gets. So we'll stop for now, and we'll catch you in question 2 in all probability. Yeah.